Alright, I have our operators and expressions project open, and in this video I'm going to go through them as slowly as possible and try to give as much detail as I can to illuminate how each one of these work. The first thing I'm going to do is define what is an operator and what is an expression. So far all we've done is declare variables and assign values. So it's assumed at this point that we understand that a variable is a typed location in memory that can store a value of a particular type. So going from there, the question is, what is an expression and what is an operator and what can we use them for? So the two kind of go hand in hand in most cases. I'll start out with an expression. An expression is quite simply a sometimes complex phrase that always boils down to one value. So I guess there's an easier way to say that. An expression is really a value that needs to be computed. So for example, 1 plus 1 is an expression, and the value of that expression is 2. And no matter how complex the expression is, as long as it results in a single value, then it's an expression. So in a way, an expression is also a value. It just has yet to be determined what that value is. It needs to be computed. So operators are symbols in the language that have a very particular syntax and do something. That's why they call them operators. They perform an operation. And the reason I said that sometimes and often operators and expressions go together is exactly the example I just gave. So if you look in this section I have right here that lists the arithmetic operators in the C# language, the first one is the addition operator. So the example I just used, 1 plus 1, is both an example of the addition operator, that being plus, and also an example of an arithmetic expression. So if I declared a variable named x that was an integer, and then I assigned it the value of 1 plus 1, I would be using the addition operator to form an arithmetic expression, and when that expression was evaluated while the program was running, the value of that expression would be 2. So that's the basics of expressions and operators, and I'm going to go through all these operators and show you how they work. And I just want to really emphasize the goal of this is not to completely memorize all the operators. Nobody memorizes well, most people don't memorize an entire language. The goal is to be familiar. So when you see somebody else using it or you see it being used, you say, yes, I've seen that before. I understand what I'm looking at. It's not necessary in your first semester to be able to recall exactly how every operator works without looking at a reference. So don't try to memorize them, just try to understand the basic fundamentals of what they're doing. The list that I've given here is the operators that I think we may use in this class, but for a complete list, you can always go to MSDN and check it out. So with that being said, I'm going to kind of run through these twice. The first time I'm just going to run through this list here and talk about them, and then I have code examples below. And we're going to revisit them a little bit when I come back in the last video and I go over my example 5, which was my Chipotle calorie calculator. So you'll see some more examples in there. But for now, let's just run through this and talk about each operator and how it works. So we've already seen this one. I told you when we're declaring variables and assigning values, you can't teach that without using the assignment operator, because the purpose of the assignment operator is to assign a value to a variable. And the way it works, the syntax of the assignment operator is there must be a variable on the left and there must be a value on the right, and those two, the variable and the value, must be of the same type. It will take the value on the right and put that value into the variable on the left. So if you have integer x and you say x equals 5, you're using the assignment operator to put the 5 into the x. So we've already talked about that one at some length. These next two operators, the increment assignment and the decrement assignment, are similar to the assignment operator, but instead of saying whatever is on the right is going to replace the value of the variable, the increment assignment operator says I am going to keep the current value of the variable, but I'm going to add whatever is on the right to it. So if you have an integer with a value of 1 in it, and then you say x plus equal to 10, it's not going to replace the 1 with a 10. It's going to add that 10 onto it. So the value, the resulting value will be 11. The decrement assignment operator, same exact thing. If you have an integer with the value of 20, and you say 20 minus equal 9, then the value of x will be 11 after that. So those are pretty simple. Those are the assignment operators. You don't really use these that often, but this one, probably the most used operator in the language. So then we get on to the ones that actually go hand in hand with expressions, and you'll find that these 4 are pretty much, I'm probably not going to need to tell you how they work. You've all been doing arithmetic your whole life. Addition, subtraction, multiplication, and division. Let's see, is there anything I need to say about these? Well, just to be specific, the plus operator will take what is on its left and what is on its right and attempt to add them together, obviously. So, we might think of it just as human beings in the way we write mathematics, and we say, oh, it's just 1 plus 1. But remember, the way the computer or the C#.NET compiler is looking at this, it's looking at it as a very specific syntax. And the syntax of all of these arithmetic operators is there better be something on the left of me, and there better be something on the right of me, and I better be able to do what I'm supposed to do to those things next to me. So, in this case, if we say 5 plus 5, that guy right there is pretty happy at this point because he sees a 5 on his left and a 5 on its right, and he knows that he can add those two things together to evaluate the expression as the value 10. And all these 4 arithmetic operators are the same in that fashion. They want the thing on the left and the thing on the right to be valid values for them to do their job. And just like assigning values, you can use literal values, you can use variable values. So you could see the expression 5 plus 5, or you could see the expression x plus 5, as long as x is a number. That's pretty much it for the arithmetic operators. There's a lot of tiny details and nuances, but we'll explore those and kind of experience those as they come. I think those are better off. The nuances of those are better off as surprises than as learning them up front anyway, because then you will remember them. The increment and the decrement operator are kind of, what's the word? They're kind of just utility or convenience operators, just in case you want to add 1 or subtract 1 from a number. Like say you have x and it's 10, and you're like, I just want to add 1 to it. It's really annoying to have to say x equals x plus 1. So instead of doing that, you can just say x plus plus, and that's a valid instruction to add 1 to your variable. And same thing with minus minus, it will subtract 1. So those are the arithmetic operators, very, very basic, and the purpose of these is to form arithmetic expressions, and those expressions can be computed so that they will result in a single numeric value. So I'm going to repeat that one more time because that's the gist of this whole section here. The purpose of the arithmetic operators is to form arithmetic expressions, something like 5 times 2 plus 3. That would be an arithmetic expression. And these operators, one at a time, since this is a program and the instructions are performed one at a time, it will simplify one step at a time the expression until finally it results in one single numeric value. That's what makes these arithmetic operators, and that the resulting value of the expression is always a number. So the reason I'm accentuating that so much is because this next set of operators does not deal with numbers, they deal with Booleans. So what actually in C#, when you see the type for a Boolean variable, it'll just be bool. So you'll see like bool b or something like that, or bool is okay. So it's just lowercase b o o l. So a bool is is a variable that can only have two possible values, and that is true or false, and it must be all lowercase. Those are keywords in the language, and you'll see that when we scroll down a little bit and show some of the code examples. So these are a little more, I mean, they should be intuitive, but they're certainly not as obvious as the arithmetic operators. So let's just start with the AND operator. The AND operator, similarly to all the arithmetic operators, looks to its left and looks to its right. So you'll have something like B1 and B2, where B1 and B2 are both Boolean variables. Or they could be literals. Maybe over here it just says false. As long as this operator has a bool on its left and a bool on its right, it can evaluate the expression, because Boolean operators are supposed to boil down the expression to either true or false. So all these Boolean operators, when they're done doing their job, at the end of the day, you'll have a true or a false, unlike arithmetic, where you'll have a number. So if I have two like meaningful named bool variables, like you know, is after lunch and and is hungry. I'll maybe say is after noon. Right? That might be something you see in some code that has to do with food. So what the AND operator does is it looks to its right and it looks to its left, and it will perform an AND operation. Oh, what is an AND operation? Well, it's exactly what it sounds like intuitively in real life. Both of those values on the left and the right have to be true in order for the expression to be true. If either of those or both of those are false, the whole thing will be replaced with false. If both of them are true, then it will be the expression will evaluate to the Boolean value of true. So how shall I say this? You know, that's what the word AND means in English. Obviously, both things have to be true, or all multiple things need to be true. You know, you can keep chaining these things together as much as you want, and X and and Y and Z. So you can keep doing this as many times as you want, but you know, at the end of the day, the whole expression has to boil down to one single value, true or false. So I don't expect you to have completely mastered the idea of the AND operator just from that, you know, terrible explanation, but you should understand that it's trying to find a yes or a no. So it's trying to decide, hey, I've got an expression here. The person who programmed this is looking for a true or a false. They're looking for a yes or a no, and that's the job of all of these Boolean operators, to try to figure out if the expression is true or if the expression is false. So the OR operator is just like the word or in English. So if I said is hungry or is after noon, well, now the whole expression will be true if either of them, you know, not both of them, both of them no longer have to be true. Even if only one of them is true, the whole expression will be true. And if this is a real program, then that's a pretty lenient expression, because it pretty much means I can go eat anytime I'm hungry. So the simple explanation is AND looks to both sides, the right and the left, and both bool values have to be true for the expression to be true. Or we'll be happy with just one of them being true. But if both of them are false, then the whole expression will be false. The not operator is a funny one, because it will take any Boolean value and just reverse it. So if I have a variable called b and it's true, and then I say that reads not b, then all of a sudden that means false. If I have a variable called like everything is okay, and the value is true, that would make it false. So you know, you might ask like, oh, when am I going to use that? Well, I'll show you in a couple seconds, but just to give you an idea, you know, you might have some logic. You might have a loop or something that says keep going while or either keep going while everything is okay, or stop when something is bad. So you know, you might want to say keep going while it's not bad, and that literally reads not bad. So you know, the best code usually reads like it's in English. So sometimes you have a not making more sense when you read it out loud, and it just helps your code read a little easier. Okay, this one, the equals operator. Now this is very important because first semester students will invariably get it confused with the single equal sign, which is the assignment operator. So just to be clear, the purpose of the single equals is to put a value into a variable. The double equals does exactly what you would expect the single equals to do before you learned how to program, which is compare are two things equal. So if I have two variables, x and y, that are both integers, that will, let's see, if x has the value of 5 and y has the value of 5, then this expression will be true. If those two values are not equal, then the expression will evaluate to the value of false. And again, they don't have to be variables, they could be literals. You could have a 10 over here. So if x is equal to 10, that will be true. If x is not equal to 10, that will be false. And then all of these down here are pretty much behave the same exact way, except this is checking to see if the two things are not equal to each other. This one is checking if the thing on the left is greater than the thing on the right. This one is checking if the thing on the left is less than the thing on the right. This one is checking if the thing on the left is greater than or equal to the thing on the right. And this one is checking if the thing on the left is less than or equal to the thing on the right. So these pretty much are all very similar. And all of these are resulting in a Boolean expression which is computed to a single Boolean value. So, having explained all of the operators and how they form expressions, I have code obviously down here that goes through some examples, some very rudimentary examples. So let's see what I've done here. I've commented after every instruction, and I've also shown what the value should be afterwards. And then when I'm done explaining all these lines of code, we'll debug through it really fast just to verify. I think I did this math in my head, which is always a bad idea for me. So I declared an integer, number. And the comment says I declared a variable, and it's an integer, so the default value without setting it will be 0. So the first thing I did was I used the assignment operator to assign the value of 10 into the variable number. So number should have the number variable should have the value of 10 after that instruction. Third instruction, I'm incrementing it. So number is plus equal to 10. Now this is the increment assignment operator, which means it will not blow away the value, it will just add whatever is on the right to the existing value. That's why we have a 20 over here, because the existing value was already 10, and then we added another 10 to it. So now the value of number is 20. The next line of code says take whatever is already in there, don't blow it away, but subtract 5 from it. So it goes down from 20 to 15. The next line of code is my first expression. I have number equals 50 plus 50. So I want you to look at the syntax of this line of code really carefully. So from the first couple of lectures, we know that the assignment operator works by putting the value on the right into the variable on the left, as long as they're the same type. And when you see the assignment operator like that, you should say to yourself, the variable on the left and the value on the right must be the same type. And when you look at this line of code, line 43, you look at number and you say, okay, well, number is an integer. So therefore, the value on the right must also be an integer for this to be a valid instruction. And it turns out that what I have over here on the right is an expression. It needs to be an integer, and it is an integer. So that's the point I'm trying to make, is that when you look at an expression like this, you say to yourself, that is a number. You might not be sure what the value of that number is yet. In this case, we do, because we're using literals. But it could have been adding two variables together. But that's okay. The point is, when you see an arithmetic expression, you can say to yourself, that's a number. So since we see that this is a number, and we're trying to put a number into a variable which is also a number, that's totally fine. So I just want you to be able to visualize expressions as a single value that has yet to be computed. So it's going to take this expression, the addition operator is going to say, oh, what's on my left, what's on my right, add the two 50s together, that becomes 100. And since this is the plain old assignment operator, it's going to completely blow the value of whatever is in the variable away and replace it with 100, and that's why it should be 100. Okay, so that's probably the most, this line, if you understand that line, probably all the rest of this is just cake. So Next one, it says number equals 10 minus 10. Well, this is the same exact thing. We're just saying evaluate that expression. 10 minus 10 is 0. Put that value into the variable. So that should be a 0. Same exact thing here. Evaluate this expression. 2 times 100 is 200. Put that value into number. Should be 200. Next instruction says evaluate that expression. Divide 100 by 2. That's a 50. Take that value, which is 50, and put it into the number variable. So it should be 50 after that. This line says add 1 to the existing value, up it to 51. Next line says decrease it by 1. So it'll go back down to 50. So these are some pretty basic usages of arithmetic operators and the basic operators we've already described. So now we move on to some Boolean Boolean expressions and Boolean operators. So I've declared a Boolean variable called OK, just for lack of creativity. And the default value of a bool is always false. So this is false. And you know, these aren't really meaningful examples, but we'll get into some meaningful examples pretty quick once we get into the assignment and once I show you my example 5, I think. If not, I'll throw some other stuff in there. But these are still valid. So declare the variable. It's a bool. It has an initial value of false. So the first thing is an example of the AND operator. If we look at that, we say, well, okay, well, let's do this one more time as we did before. We say, okay, we're using the assignment operator, and there's a variable on the left, and the type is bool. So the value on the right that I'm putting into that variable had better also be a bool. So let's go look at what's on the right, and we see it's, well, true and false. Well, that's the AND operator, which is a Boolean operator, which will give me a bool, which is exactly what I wanted. So the bool value goes into the bool variable, and all is right with the world. The question is, what is the value actually going to be? In this case, I'm using literals, so I know that true and false is false, because the way the AND operator works, both sides have to be true. So we're still going to be false after that line of code. The next one is going to be evaluate this expression, and the value of that expression is true, because with an OR, either one of the sides, the left side or the right side, being true will make the entire value of the expression true. So now, after that, OK should be true. And now I say I want OK to be not true. Well, not true is obviously false, so OK should be false after that. Next line, I'm saying set the value of OK to whatever this expression evaluates to. Well, what does the equals equals operator do? It tells you if the thing on the left is equal to the thing on the right. And obviously in this case, 1 is not equal to 2, so this expression is false. So the value of OK will be false. Same thing down here, evaluate this expression to come up with a bool value. 1 is not equal to true. I knew I was going to do that when I said that one. 1 is not equal to 2, which is true. So we're going to have a true that we set into the value of OK. And now we get into the greater than less than. This next one says, is 25 greater than 200? No, that's false. So that expression will evaluate to false, so we'll stick the false into OK. Same thing for the next bunch. 25 is not less than 200. 25 is not greater than or equal to 26. 25 is less than or equal to 25. And now I get into a couple of funny things here. I say expressions can get complicated. You can use parentheses, I don't know if I spelled that right, to enforce precedence. So I don't really want to give you guys a whole ton of terrible examples, because you should be able to figure this out on your own. The point is, you know, I think what we learned, like the rules of order of operations in grade school, so those should still hold true even if you don't use parentheses. But if there's any doubt in your mind that the operations are not going to be executed in the right order, then, you know, put parentheses around stuff. For example, this will ensure that the 4 times 10 happens and the 4 times 100 happens, and then it will use 40 plus 400, and it will take those two. Basically, here, let me do it this way so it's easy to visualize. It'll take the 4 times 10 and it'll replace that with 40. It'll take the 4 times 100 and replace that with 400. It will take this whole thing and replace that with 4,440. Oh, I totally didn't do that on purpose. And then finally it will evaluate that as whatever that value is, and it'll be one single numeric value. So long story short, you can use parentheses to enforce precedence if necessary. But another reason why I used this example was because I wanted you to see that sometimes you end up with expressions that are not very easy to read. At least maybe not. You know, everybody's different. So, but what I said down here is another useful trick is to break down expressions into smaller variables. This is known as a more semantic approach. So we pluck these aspects out and we put them into semantic. Semantic just means words, descriptive words, to describe the actual pieces of the expression. And maybe that's a little easier to read for you. So I declared a variable for the 4 times 10. I declared a variable for the 4 times 100. I declared a variable for the 3,000, another one for the 1,000. And now, you know, I can compute total pounds by adding all those together, and my final expression is total pounds divided by 2,000. This is a more semantic approach. This is a more terse approach. Both of them will do the same exact thing, and it's up to you which you like better and which you think other people will be able to read easier. One more thing. The plus operator can also concatenate strings together. And this is, I'm not sure if this is a great example, but before I look at that, we'll say this. If I have, if I say string s equals hello plus a space plus world, oops, that's the simplest example, I guess. So the plus operator not only knows how to add numbers, but it can also not add, but it can concatenate strings. So it'll take those two and basically link them together to form one string, which is that. And then this plus knows how to link these two strings together and concatenate them to make that. So you can take multiple strings and concatenate them into one string very easily with the addition operator. So what this example is doing down here is I'm saying I have a 10 and a 20. I guess I have a point in 2D space, and then I'm creating this formatted string to basically be a pretty looking version of my point. So if you break this down, this value here, again, let's do this one more time just to be safe. Assignment operator is right there. That means there's a variable on the left and a value on the right. The variable on the left is of type string, so the value on the right better be of type string. And I look at this huge abomination over here and I say, is that a string? Well, if I look what's going on, I have a literal string plus a number plus a literal string plus a number plus a literal string. So if I put a bunch of strings and numbers together using the plus sign, or the plus operator, is that going to result in a string that I can put in my string variable? And the answer is yes. Because once you start, the language is smart enough to know that once you start using strings and the plus operator, even if you throw some numbers in there, it's smart enough to realize that you're trying to concatenate a big string. So what it's going to do is it's going to evaluate and simplify this expression one step at a time. And I'm not sure if it starts on the right or the left, but it really doesn't matter. So it'll start with maybe this plus here, and it'll say, oh, okay, I'm supposed to concatenate the y-coordinate and that the literal string value of that bracket. And the y-coordinate value is 20, so it should replace this whole expression right there with that. So then this plus over here looks to its left and looks to its right, and it says, oh, I have two literal strings. I have a comma and I have 20 with a bracket. So it just concatenates them like that. And then this plus, this addition operator, says I have a number over here on the left and I have a string over there on the right, and the value of x-coordinate is currently 10, so it's going to concatenate these together like that. And then the final plus is going to say, I'm just concatenating two strings, and it's going to end up looking like that, 10, 20.
So maybe that makes a little more sense as to what I was doing here with trying to create this formatted string from my xy coordinate. So now I have a nice pretty little xy coordinate enclosed in brackets with a comma in between them. So to accomplish that, to get that value into memory, I had to do this. Oops, I had to do that. So that is it. So let's debug through this thing and just watch it all work, and that'll be it. So I think it will start on line 40. We shall see. Got it in debug mode. I'm running it. It's going. The windows are all jacked up. For some reason my locals is huge and in the middle of the screen. So I'm going to grab the locals. I'm going to drag it down to my bottom anchor. Ah, there we go. There's the view that I am used to. And as we can see, it's frozen on line 40. So it hasn't done anything yet. It's about to execute line 40. So I'm going to debug through this one line at a time by hitting F10. Also, there's the little arrow there, the step over arrow, but I'm just going to keep hitting F10 because its keyboard is easier. So according to all this, number should get set to the value of 10, and it's 10. Then it should be 20. Now it's 20, 15, 100, 0, 200, 50, 51, 50. So looks like my math worked. I would have been really embarrassed if that didn't work. So OK should be false, and then true, and then false, false again, true, false, false, and then true. And I wonder how the IDE is doing these days. I wonder if I highlight an expression and I hover over it, would it'll tell me the value of it? Guess not. Oh, we'll talk about that later in class. So now this guy here is going to evaluate this entire expression and come up with, if I recall, 4,440. Oops, what happened? Oh, right, because it divided it by... Oh, I'm glad that happened. So remember how I said at the beginning we can discover the nuances of the arithmetic operators as we go? Well, here's a nuance of the division operator. This is actually division in... sorry, what did I say? This is actually integer division. I put the wrong emphasis on the wrong syllable. This is actually integer division. So it took the 4,440 on the left, divided it by 2,000, came up with 2 dot something, and cut off the rest of the number. There's a way around that, and I'm just not going to talk about it right now. But that it's a technique called casting. We'll talk about it later. But be aware that this is integer division. So that's why it said, oh, I'm sorry, I don't know how to compute a decimal. So I'm just going to take 4,440 divided by 2,000. You get 2, and I'm going to chop off the remainder. So that's why we got a 2 there. So now here in this case, now we break this up into a bunch of smaller values, and I can hover over these over here. Weight of the tires, 40, weight of the seats, 400, weight internal, 3,000, weight of the body, 1,000, and now total pounds, 4,440 divided by 2,000. Because this is integer division, will result in... Oh, why did it work that time? Alright, so there's actually quite a bit of detail that I'm not really wanting to talk about right now, in like how it decides whether or not it's going to treat a number like an integer or a double. But I'll think about it for a few minutes before I do the next 2 videos, and I'll come back to that. But for now, when you're know that when you're dealing with division, you have to be careful that there is a distinction between integer division and decimal division. So I'll come back to that and go through the details. That's not really that important for the purposes of understanding these operators. So x coordinate equals 10, y coordinate equals 20, and now my beautiful formatted string should look exactly like I had it, and there it is, 10 comma 20 in brackets. Alright, so that's that. That is operators and expressions. Like I said, you don't have to memorize them, just be familiar with them. And I'm going to go on in the next video to talking about how to get input from the user through the console window, and also to print out values to the console window so that we don't have to
rely solely on debugging to see what's going on in there.